Okay, and this is the last question in 2.6. So this one is, make sure my pen is on. Okay, so this one is 2.6, number 10, I believe. Alright, so let's see what we have here. Police car is located 50, so let's put the road. So let's say the road is here. And the police car is located 50 feet to the side of the road. So the police car is located about 50 feet this direction. Alright, and the police car, the red car is driving along the road, so we have some car that's going to be moving in this direction here, evidently towards the police car. How do I know that? Because this says the rate's decreasing. So if I actually fill in the rest of this right triangle, I know then that this side, so if I label these things, I'll call this A, I'll call this B, and I'll call this C. So if this is true, then the police car is actually pointing with some kind of radar gun towards the car, and so dc dt is equal to negative 95 feet per second. So the car is getting closer to the police car. And A, by the way, equals 150 feet because it says up the road. So 150 feet up the road from the location of the police car. The police radar reads that the radar is decreasing. How fast is the car actually traveling? So how fast is the car actually traveling? I'm trying to find dA dt. Okay, so let's see how I would actually do this. So the first thing I need to know is that it's a right triangle, so I'm going to be able to use the Pythagorean theorem. So I can write a squared plus b squared equals c squared. If I take the derivative with respect to time, I'll get 2a dA dt plus 2b dB dt equals 2c dc dt. Alright, so the thing that's we have to clean up in this formula is to notice that the distance from the road to the police car is not changing. The police car is stationary. So here's the police. This is my road. And so the police to the road is not moving. So that means the change in distance over time from the police car is actually 0. So this is 0, which means this whole term gets wiped out. Alright, so what I need then is I actually have everything I need except C. So I'm going to have to use the Pythagorean theorem to actually figure that out. Alright, so let's see here. We're going to have 150 squared plus 50 squared is equal to c squared. So I don't run out of time, I'm going to do this work off I'm going to pause the video. Okay, as you can see, I've done the problem over here on the right. If you're good with radicals, you can see that I can simplify this to 50 radical 10 equals c. Now let's plug in. So I have 2, we have a is equal to 150, so I put 150 here, times dA dt. dA dt is what we're actually solving for, so I'll leave that in here as my variable. This would equal 2 times the 50 radical 10 dc dt, which is negative 95 feet per second. Alright, I'm going to again go off camera here and or off the video to get my answer because I'm running out of time. Okay, so if you look at the work that I did here, if I multiply this together on the right hand side, then divide by 300, I end up with negative 95, which is about negative 100.139, and that is feet per second, and it's negative because the distance is decreasing, but we wouldn't put the negative sign in the problem because it's asking for speed. So it would just be 100.139. Alright, good luck.